Hello dear friends, welcome to Gate Academy Global. Before starting today's session, I would like to have the input as well as the concurrence regarding the quality of video as well as audio. If both had been perfect, just write perfect over the like chat, and then we are going to go ahead with the today's agenda. As it had been clearly mentioned over the thumbnail as well as the title, we are going to play the marathon over the analog. But the way of playing marathon is been a bit different. What I am going to do, I am just going to take numerous number of numericals from the analog circuit. Around 2 minutes would be given to you guys to get its answer. Whatever the answer you are getting, just you have to type over the live chat, and after the 2 minute gets over, we will be solving that problem. But for the each and individual problem, we are not going to give more than 4 to 5 minutes, because if I'll start giving more than 4 to 5 minutes, definitely your interest level would go down, and before the gate examination you yourself would be trying to have a plenty amount of questions within a shortest span of time. So we have got a good amount of questions in front of you, and yes, we would be giving around 2 minutes for the each and individual question. Whatever the answer you guys are getting, you just have to type over the live chat, and then within 2 to 3 minutes I would try to explain that problem and we will move forward for the next question. So here I am not going to cover any sort of theory. We will just be playing around the numericals, the different kinds of numericals. Either the problems are being the concept based on the concept of operational amplifier, whether this has been the based on the concept of BJT biasing, MOS biasing, amplifier, RE model, H model, whatever it could be, Is that part clear? Good morning, Divya. Good morning, Swarif, Abhijit. Very warm good morning, dear. Anyways, let me focus over the first question which had come in front of you. The problem states, for the circuit shown below, this has been a circuit, just not this one. We had to start from the question number first. Yeah, this has been the first question of the day. Consider the circuit shown below. The output voltage V out in volt is. I need to get the answer from each one of you. Take your time, not more than 2 minutes. Probably if the question gates come in gate examination, probably it would carry the weightage of 1 mark. Tell me what could be the best most answer for this given question. Here we had a voltage source of a 3 volt where the polarity has been negative upside, positive downside. This has been an ideal operational amplifier where the saturation voltages are being given 1 volt and minus 1 volt. Tell me what would be the best most answer for this given question. Answer have started coming. As per the Swarit Mahaleshkar, the answer has been -1. Anyone else apart from Swarit? Two minutes are being given to you guys. It's been 10:04. So we would expect your answer till 10:06. Sir, it is a practical operational amplifier, obviously. Apart from the saturation voltages, each and every remaining parameters are being ideal, like input impedance, output impedance, voltage gain. So almost it's been a type of ideal operational amplifier with given saturation voltage Vset. Yes, this has been the first question of the day. So the answer have started coming. Most of us are being giving the answer as -1. I would like to know whether the -1 has been the right answer or wrong answer. So as far as this problem is being concerned, most of the people are been giving the answer as -1. So most of the students are being given the answer as -1. Anyone else apart from the 4 or 5 different answers we have received so far? As per the Saraswat, the answer is being 3. All of the answers are wrong. See, whenever the saturation voltages are being given in your problem, no, you also had to see whether your operational amplifier is going into the saturation mode or not. If it is going into the saturation mode, if it goes beyond +1, it would get saturated at +1. If it goes beyond -1, it would get saturated at -1. And if the output voltage remains in between -1 to +1, whatever the output voltage we used to have, that voltage would get reflected towards the output side. My dear friend, I do not know how far you could see this problem, my dear friend. The polarity has been upside negative, downside positive. And this operational amplifier has been a standard inverting operational amplifier. And may I know what used to be the gain offered by the standard operational amplifier? The standard operational amplifier, inverting operational amplifier, gives the gain of minus RF by R1. Yes, so that the output is supposed to be minus RF by R1. This has been the feedback resistance. Obviously, it is going to be minus of 10 kilo divided by this resistance is being replaced of R1. So it's going to be 10 kilo. And now it is going to get multiplied with a minus 3 volt. 10 kilo knocks off. Minus 1 gets multiplied with minus 3 becomes 3 volt. And as the 3 volt is trying to go beyond plus 1 volt, the output would get saturated at plus 1. Nobody had seen this polarity, and probably that is why they had done this mistake. So may I know what would be the best most answer? The best most answer is gonna be plus of 1. Plus of 1. Is that part clear to all of us? Yes. Many of us had given the wrong answer at very first instance, but after that they had given a correct answer. So this has been the first question of the day. The answer has to be plus of 1. Plus of 1. Had you enjoyed this problem? Probably almost all must have enjoyed this problem. Suddenly they had given the wrong answer, and this sort of mistake can take place in GATE examination, and you had to avoid. That is why I have brought this many questions in front of you, so that you will be a little bit more comfortable while GATE examination. So this problem had come in front of you. We had a diode, we had a voltage source, current source, and you had to calculate the diode current I of D. Consider a circuit shown in below figure. This has been a circuit. The value of ID has to be calculated. Again, the 2 minute had been allocated to all of you. This has been 10, 8. So till 10, the 2 minutes is being given to all of you. 2 minutes are being given to all of you. Tell me what would be the diode current I of D. Yes, Himanshu, if nothing has been given regarding the diode, whether it's been the forward resistance, whether it has been a cut-in voltage, definitely the diode has to be assumed as a ideal diode. Many of the times this sort of problem is being come in GATE examination where nothing had been provided regarding the diode, so diode has to be taken as a ideal diode. GATE sorts Krishna. As per the Krishna, answer is being 1. Anyone else apart from Krishna? At least I need 6 to 7 answers, then only we will proceed further for its detailed analysis. And I said it has been communicated earlier, the 2 minute would be given to you guys, and within 2 to 3 minutes I would solve that problem and we will go into the next problem, so that within a concise frame of time we can do many number of problems. As per the Subham Mugale, the answer has been 1. Subham, only one time you had to put your answer. I can see your answer once. Yeah. Ravi Teja, answer has been 1. Varshit, answer has been 0. My dear, whoever given the answer is 1, the 1 is been the perfect most answer for this given question. My dear friend, if you have the juggleries of the circuit which had been connected to the anode and cathode side, you had to simplify that circuit with the help of either Thevenin theorem or Norton theorem. Once you're done with that, definitely you can smash that problem within a fraction amount of time. See what had been happening, what I had been doing, I had taken its equivalent Thevenin resistance and voltage, and same goes in this side as well. So here RTH and VTH, as we had the two sides, let's take this as been the first side, so the equivalent resistances are been RTH1, RTH2, and similarly VTH1 and VTH2. My dear friend, how the equivalent Thevenin would be applied at this point? My dear friend, you had to talk about the voltage across the 4 ohm. This complete circuit is being isolated. So here it becomes 10 into 4 divided by your 4. So if we'll talk about VTH1, so it's simply gonna be 4 divided by your 4 plus 4, that's been 8 into of 10 volt, and that had been 5 volts only. Similarly, if we'll talk about the RTH1, In case of calculation of RTH1, all of the independent source would be killed. If it has been voltage source, it would be short circuited. If it has been current source, it would be open circuited. So what would happen? In this case, obviously, this would become short circuit. 4 and 4 would come in parallel. So the RTH1 is being 4 in parallel with 4. Result is being 2 ohm. In the same sequence, we would also be talking about VTH2. Again, this would be completely isolated. This current all the way is been coming from top to bottom. So obviously, the amount of voltage would get dropped across the 1 ohm is being 2 ampere into 1. So VTH2 is being 2 volt. 2 volt. And if we'll talk about the RTH2, again the same process has to be followed which we had followed earlier. We will look into the effective resistance between this two terminal, keeping all of the independent source out. If it has been current source, it's been open circuited. So simply it's been 1 ohm. So the equivalent circuit would become, see how the equivalent circuit would become. Here the RTH1 would come and that had been 2 ohm. Similarly, here VTH1 would come, that had been 5 volt. Here the diode is supposed to come, and similarly here the RTH2 that had been 1 ohm, and similarly VTH2 that had been 2 volt. And you yourself would be able to understand now this diode is going to get conducted because the 5 volt is going to connect towards the anode side and 2 volt is going to get connected towards the cathode side. So may I know how much amount of current we are going to have? First you take this diode as a short circuit, and now easily you can apply a KVL, and as per the KVL, 5 minus of 2 divided by of 2 plus of 1 would give you the amount of current which the diode possesses is gonna be 5 divided by of 3, sorry 5 minus of 2 divided by of 3, and that had been 1 ampere. So as far as this problem is being concerned, the best most answer is being 1 ampere. Best most answer is being 1 ampere. Is that part clear to all of us? Good morning, Chanchal, good morning. Yeah, source transformation. So probably this problem must have been understood to all of us. In the same sequence, let me move into the next question as well. So here comes the question number 3 of the day. Again, we had been dealing with a ideal operational amplifier with the saturation voltages are being given. Many of these students also call this operational amplifier as a practical operational amplifier. That's true. Now, with this juggleries of the circuit, we had to find its output voltage V0. May you know what would be its output voltage V0? Again, the 2 minutes have been given to you guys. Within the 2 minutes, you had to answer this problem well. Here the ground has been connected to the 10 kilo ohms resistance, and here the 3 volt source is been connected to the operational amplifier. Here the saturation voltages are being given, and that's been plus 12 minus 12, and here the V out has to be calculated. V out has to be calculated. The answer have started coming. The first answer had come from gate sorts. The answer is been 6. Anyone else apart from 6? Anyone else? 8. 6 is wrong, 8 is wrong. Three is also wrong. Tapas Nayak, 9 is wrong. Tapas Nayak, 3 is wrong. Wrong. Tapas, I would request just give your answer once. 6 is wrong. See, what had been happening in this problem? Rarely this sort of question do get asked in gate examination. The 3 volt is directly connected to the inverting terminal. What does that mean of it? That means the inverting terminal voltage is being prefixed at 3 volt. Whereas At non-inverting terminal, no voltage is being applied, and as far as the ideal operational amplifier is being concerned, it is not going to sink any amount of current. And if it is happening, so the 10 kilo is not going to get dropped any amount of voltage. Whatever the voltage we were having at ground potential, the same voltage would get reflected at non-inverting terminal as well. And now you yourself would be able to understand forcibly, now at inverting and non-inverting terminal, the two different voltages are being connected. This operational amplifier is not working in linear region, it is been working as a comparator, and or I can say it has been working in a saturation region, where the output would have only two discrete possible output, and that had been either plus Vset or minus Vset. And once you'll see this problem well, the value of V plus is being set at 0 volt, and the value of V minus is being set at plus 3 volt, or I can say V minus is being greater than V plus. What does that mean of it? That means the output has to be saturated at minus V set side, and as far as this problem is being concerned, the value of minus V set is been minus of 12 volt. So may I know what would be the value of V out? It is going to be minus of 12 volt. I know many of the students must have used here and there, they must have used the virtual ground theory, my dear friend. In this problem, if the V plus and V minus are being forcibly maintain the two different potential, by default the virtual ground theory cannot be used, because as per the virtual ground theory, the V plus and V minus would be same, such that the gain offered by the OLTF would become infinity. Anyways, the best most answer is been minus 12. Minus 12. No buffering. Tapas, everything is going fine. From my side, there had not been any problem at all. So is that part clear? So the student who had given any answer apart from minus 12, they had to rethink, and they also had to extract few of the important concept if they are able to extract something from this problem. So the answer has been minus of 12 volt. Minus of 12 volt. Yes, no? Okay then. In the same sequence, let me take the next question as well. So here comes the question number 4th of the day. Question number 4th of the day. Again, the 2-minute span of time is been given to you. The problem states the operational amplifier circuit shown in figure is, this has been the complete circuit, it's been a type of precision half wave rectifier, precision full wave rectifier, peak detector, level shifter. Tell me what could be the best most answer for this given question. Again, the next 2 minutes are being given to you guys. Within the 2 minutes, you had to give the answer for this given question. Tell me what could be the best most answer for this given question. Again, the next 2 minutes are being allocated to you guys. Which kind of the circuit it had been? Precision half wave rectifier, precision full wave rectifier, peak detector, level shifter. The first answer had come from Jay Singh. As per him, the answer is been A. Anyone else apart from Jay? Sir, half wave rectifier according to me. Swarit. Divya Darsani states the answer could be A. Anyone else apart from the 3 different answers we have got it so far? Anyone else? Chanchal, answer is been A. Very good. Abhishek, Chanchal, Divya, Swarit, Jai Singh. Extremely well. The best most answer for this given question is being option A. It's been option A. If you try to understand from where this answer had come, just take the example in this way. At very beginning, I have assumed the diode is being off, and as the diode is being off, there had not been any feedback, and as there had not been any feedback, always the operational amplifier is going to get saturated. So what had been happening, my dear friend, if we had taken V in greater than 0, now V in is being greater than 0, so all the way this V in is being connected to the inverting terminal, and the non-inverting terminal is already been connected to the 0 volt. So I can say in that case the V minus is being greater than V plus. Yes, V minus is being greater than the V plus, and in that case what had been happening, the output is supposed to get saturated. The output is supposed to get saturated at minus of V set. And if the output gets saturated at minus of V set, this diode is going to be off. The diode is going to be off because the negative polarity is going to get connected towards the anode terminal of the diode. diode is been off. And as the diode is been off, you yourself would be able to understand the equivalent circuit is going to be something like this. Here, a certain positive voltage is been applied. Here comes a 1 kilo. This has been the grounded, minus, plus, and this has been 1 kilo, 1 kilo. I had been taking the voltage across this terminal, and keep in mind, this has been the open circuited. This has been the open circuited. You yourself would be able to understand what would be the voltage over here. May I know what would be the voltage over here? So obviously the voltage would be clearly known to all of us. The output voltage is being simply 0. Output voltage is being simply 0. Yeah. So when the input is being greater than 0, the output voltage is being 0. Similarly, if I take another situation when the Vin is being lesser than 0. When the Vin is being lesser than 0, what would happen? Again, the diode is supposed to be off. Now this would saturate, and this would saturate at a positive sense, plus of Vset. And in that case, the diode gets on, and as the diode gets on, now the feedback is being injected. And as the feedback is being injected, now it had been a perfect in operating linear region. And in that case, the equivalent circuit is going to be something like minus, plus, 1 kilo here gets grounded, V in 1 kilo, 1 kilo, yes, and this has been short circuited. If nothing is been given, you assume V cut in is equals to 0, and you had to get the voltage across this terminal. I would say the voltage across this terminal. So the V naught is been minus of RF by R1, that had been minus of 1k divided by 1k into of V in. So it had been minus of V in, or mathematically speaking, this has been V naught is equals to of minus of V in when the V in is being lesser than 0. 0 for V in greater than 0. Obviously, it had been a invert half wave rectified output. Invert half wave rectified output. Or I would say, if the input has been a pure sinusoidal in nature, may I know what would be the output? As here in this first half, the input has been greater than 0, the output would be 0. And in the second half, the input has been lesser than 0, the output would be minus times of input. So this would be this, this, and this. This is also called inverted half wave rectifier. Inverted half wave rectifier. Is that part clear to all of us? It's also been called as an inverted half wave rectifier. May I know why this is being called as a precision rectifier? If you have any sort of idea why this circuit is being called as a precision rectifier, may I know? This is called as a precision rectifier because as far as this practical diode is being concerned, the cut-in voltage of the practical diode falls somewhere in between 0.2 to 0.7. But when this diode is being connected in cascaded to the operational amplifier, ideal operational amplifier has the open loop gain is equals to of AOL. In that case, the practical cut-in voltage with this precision rectifier almost becomes 0. Anyways, this is not the right time to discuss more about how the new cut-in voltage had become 0, but yes, that is why this diode is being applied in front of the operational amplifier such that I would be able to achieve the effective cut-in voltage is equals to 0. Effective cut-in voltage is equals to 0. Is that part clear to all of us? Yes, na? Okay, then let me go ahead with the next question as well. Let me go ahead with the next question as well. So here comes the next question. Here comes the next question. This has been a perfect example of a clamper circuit. The problem states a voltage 1 plus 2 sin omega t is been applied to the circuit shown below. The capacitor C and diodes are considered as ideal. RL is the resistance of a large value. The magnitude of the average voltage RL is being. Tell me what would be the best most answer for this given question. Again, the 2 minutes are being allocated for this question. Within 2 minutes, you must be able to solve this problem well. Tell me what could be the best most answer. So this has been a circuit where the diode is being connected in such, the anode is been upside, cathode is been downside in parallel with the load resistance, and in series with the capacitance is been connected with the V in, and V in is been a pure sinusoidal with a DC voltage of 1 volt. Tell me what would be the best most answer. This has been the question number 35. Tell me what could be the best most answer. What could be the best most answer for this given question? Tell me. Again, further 1 minute is being left out, and then I would try to solve this problem in front of you guys. One information I would like to communicate: the student who had already seen my pre-schedule of control system, the control system marathon, which was supposed to conduct tomorrow and now has been shifted by day after tomorrow. That means we are going to conduct on 1st of January, precisely at the same time. So there would be a little bit change in the schedule. Anyways, the best most answer. Should I wait? Or what? The first answer had been 2. Varshit, I would request once again, if you somewhere mistake has been done, you had to correct it well. Yeah. See, as far as this problem is being concerned, now, this has been a perfect problem of a clamper circuit. In a clamper circuit, we want the discharging time constant to be almost infinity, and by keeping RL tends to infinity, we had tried to keep the discharging time constant tau discharge infinity. So obviously it had been a type of ideal clamper circuit. The next important thing, the student who had gone through the clamper circuit, they must be knowing the clamper circuit can be further bifurcated in the 2 part, the positive clamper and the negative clamper. May I know whether it's been the positive or negative clamper? As the anode is been upside and diode is cathode is been downside, obviously it is going to be a negative clamper circuit. How do we solve this? We will take the positive polarity of V in and we will go to its apex value, and with the help of that apex value the C gets charged. So may I know what would be the apex value of V in? The apex value of V in positive polarity is gonna be 2 sine omega t. The apex value of sine omega t is been 1, gets multiplied with 2 plus 1, it's been 3. So virtually speaking, the equivalent circuit is going to be something like this. Here comes 3 volt, here comes the capacitor, the diode is being short circuited. So the capacitor would get charged with 3 volt, and that 3 volt would remain in future for all of the cycle, because the capacitor is not supposed to get discharged because the value of tau discharge has been so high. May I know what would be the polarity over here? So the flow of current is being in clockwise direction, so the polarity is being positive over here and the negative over here. Is that part clear to all of us? Yes, sir. In the same sequence, if we'll go forward, this complete circuit would remain as it is. Only capacitance would be replaced by this battery with the 3 volt. Polarity should also be known to all of us. And now this diode would remain off for the next of the operating cycle. So yes, so the change has been introduced over here. This has been replaced with the 3 volt of a battery. This has been the open circuited in nature. Here comes the load resistance. R of L, and here comes your input voltage once again, and the input voltage is being nothing but a sinusoids 1 plus of 2 sine omega t. So may I know what would be the load voltage? The load voltage, I may call this as a VL. The polarity is positive over here, negative over here. So once we'll take a loop, now you yourself would be able to understand. The VL is simply gonna be 1 plus 2 sine omega t getting subtracted with 3 volt. It's not been addition, it's been a subtraction. You yourself would be able to see the current is striking the minus polarity and then plus polarity. Yes, na? So here this value has been, how much it had been? Minus of 2 plus of 2 sine omega t. And once we'll try to draw this sinusoidal curve, you yourself would be able to understand how it would look like. It would start from at omega t is equals to 0 radian, it would start with -2, and at omega t is equals to pi by 2 radian, it becomes -2 plus of 2, that's been 0. So keep in mind the 0 is been the highest value, and similarly -2 is been the mediocre most value, and the least value is gonna be -2 and -2. So put together, it is going to be a oscillating signal, yes, and it would be sort of this. It would be sort of this, yes. Agreed? No? Yes, sir. We are able to understand till this moment of point. So here goes 0 volt, here goes -2 volt, and here goes -4 volt. You yourself would be able to understand its average value is nothing but average value. If we'll calculate, it's nothing but -2. How did I know about it? My dear friend, if you take a pure sinusoidal signal, what used to be its average value? Its middle most value used to be its average value in case of pure sinusoid. So obviously its middle most value has been -2, so the average value has also been -2. Either if you want to take the reference of mathematical calculation of integration from 0 to t x of t dt 1 upon t, then also you'll be getting the same answer. Same answer. Mondiksa, good morning, dear. So the best most answer for this given question is being -2. Is that part clear to all of us? So the student who had gone through the clamper circuit must have connected this problem well. Yes. So the answer is being -2. In the same sequence, I think it's been the right time focusing over the next question as well. So here comes the question number 36. Read the problem carefully. This has been the problem from the problem of clipper. Within 2 minutes, you guys must be able to crack this problem well. Nothing new, nothing magical. Consider a clipper circuit shown in below figure. V in is being 4 volt. The two diodes are being connected, and they had been connected with the 3 volt and 6 volts. Assuming the diodes to be ideal, the value of V out is being, the 4 different options are being attached. The options are being 3 volt, 4 volt, 4.5 volt, 6 volt. Tell me what could be the best most answer for this given question. So the answer have started coming. As per the Subham, the answer is being 3. Anyone else apart from Subham? As per the Chanchal, the answer is being B. As per the Jay Singh, the answer is being B. Anyone else apart from Subham, Jay, Chanchal? As per the Srinath, the answer is being 4. The another 1 minute is being left out. Ravi Teja, answer is being 3. Answer is being 3. My dear friends, the best most answer for this given question is being B, that had been 4 volt. In this problem, the V in is not been a time varying input, it's been steadily set at 4 volt. And as it had been set at 4 volt, we can talk about the D1 and D2's behavior. My dear friend, you yourself would be able to understand. The 4 volt is going to get connected towards the cathode side, whereas the anode side is being connected to the 3 volts. So obviously, the cathode voltage is being kept at a higher potential in compared with the anode voltage. D1 is going to be off. By default, D1 is going to be off. Yes, sir. D1 is going to be off. And if we'll talk about the D2, my dear friend, here what had been happening, the 4 volt all the way comes towards the anode side of the diode 2. That means this has been kept at a 4 volt, and now the cathode is being kept at a 6 volt. Again, the cathode voltage has been higher than the anode voltage. The D2 is also supposed to be off or open circuited. And if the D1 and D2 both are being supposed to be off, may I know what's going to be the equivalent circuit over here? The equivalent circuit is going to be, you just knock this off, and you yourself would be able to understand, my dear friend. this resistance is not going to drop any amount of current because the loop current has not been formed. All the way this 4 volt would be the voltage across this terminal, and would become the output voltage as well. So the V out is being simply 4 volt. V out is being simply 4 volt. Is that part clear to all of us? Yes. Yes, na? So the best most answer for this given question is been 4. I thought the source is AC, SGD. If you think the source is been AC, still the answer would not change. No? No. The answer would not change. The answer is been 4 volt. 4 volt. In the same sequence, let me move forward taking the next question as well. Yes. A diode is biased at a current of 1 milliampere. The thermal voltage is being 0.026 volt. The change in current in microampere by VD changes by 1 millivolt is being. It is not that difficult question. If you had a little bit understanding of dynamic resistance, probably you will be able to smash this problem very well. Tell me what would be the best most answer for this given question. So again, the 2 minutes are being allocated for this question. Within 2 minutes, you had to smash this problem well. Tell me what could be the best most answer. This has been the 7th question of the day. Tell me what would be the best most answer for this given question. Keep in mind the micro is already been attached. You have to just put the remaining part. No, guessing that's been the wrong answer. Anyone else? My dear friends, this has been a problem from the dynamic resistance. What the dynamic resistance talks? The dynamic resistance talks about the rate of change in the diode current because of the change in diode voltage. And that's been nothing but dou ID divided by of dou VD. And it's also been called as a reciprocal to the dynamic resistance. I can call it 1 upon RD. And how it's been defined? It's been defined as eta. Eta is also been called as the ideality factor. Usually for the silicon it used to be 2. But if nothing is been given, you take that ideality factor as 1. And here it becomes I divided by of VT. What is been the I over here? It's been the diode current ID. Anyways, good amount of theoretical analysis has been involved while deriving the dynamic resistance. But as far as the today's marathon has been concerned, we are not going to focus over that part. Now the rate of change in I versus rate of change in VD. So this can also be written as change in ID versus of change in VD. And in this problem, the diode current is being clearly given, and that had been 1 milli. VT is been clearly given, and that had been 0.026. And in this problem, it had been clearly given. The change in VD is been 1 millivolt. So the change in ID we wants to calculate. So it becomes 1 milli into of 1 milli divided by of 0.026 2, 6. 1 milli into 1 milli could have been written as how much it is been? How much it is been? So this could have been written as 1 into 10 to the power of minus 6. So basically this factor would come as answer. 1 divided by of 0.026. 1 divided by of 0.026. And that is been coming somewhere 38 point of 461 microampere. And I would request to all of the students who can understand Hindi, we are going to have probably 6 to 7 hours, 100 questions on. First we will start with the control system, then we will go into the analog, and then we will go into the EMFT. So the complete day we are going to spend over this 100 questions based on this 3 different important subjects. Probably 35, 35 and 35 number of questions we are going to take in our Gate Academy 2.0 channel. There also my pattern would be almost same. I would not go into the detailed study of either of the question. I will show the question. Probably I am going to give you the 2 minutes and then we are going to solve that problem by ourselves. Focus over this problem. Yes, now. So the answer is been 38.46 microamperes. So only 38.46 should come over this point. Yes. So in the same sequence, we had to move forward, taking the next question. So here comes the next question. The circuit shown in figure is A. Here the Zener diode is being connected. Here the load is being connected. The 4 different options are being attached along with this problem is being constant voltage source, constant current source, common emitter amplifier, and then the common base amplifier. Tell me what could be the best most answer for this given question. Again, 2 minutes are being allocated to you guys. Tell me what could be the best most answer. Abhishek Datta, if you are able to understand Hindi, no, already the marathon is being taken place on our main channel. So you can take the reference of those video. The span of video is probably 4 to 5 hours. Within 4 to 5 hours, almost all important topics as well as subtopics is being discussed. So you can take the help of that video as well. So again, the 2 minutes are being offered to you guys. Tell me what could be the best most answer for this given question. Common base amplifier. Anyone else? Anyone else apart from one answer we had received so far? That's been the common base amplifier. Jessing is been common base amplifier. Sir, it is MSQ. No, it's been a MCQ. Only one answer has been a possible answer. It's been a MCQ. Tomorrow we were supposed to have the marathon on control system that had been shifted by 1 day, and that we are going to play on 1st of February. And tomorrow we would be completely dedicated on our Gate Academy 2.0 channel. There I would play with the 100 number of questions that belongs from control system, analog and EMFT. The answer is being C, common emitter amplifier. My dear friend, whenever this diode do come into the picture now, keep in mind always this diode is being placed for the reference voltage. Probably you must have seen in case of shunt voltage regulator and series voltage regulator. Yes, na? And now you yourself would be able to understand such a high input voltage is being applied, and this Zener diode, if must have been the VZ is equals to 5 volt or 6 volt, must have been in breakdown. And as it is been in breakdown, the current IB is being fixed. How? 10 Just try to understand in this way. 10, the voltage drop across this point and would decide the voltage across this. Once the IB is been fixed, no, what would happen? Even IE would also get fixed if this BJT is been in active region. So 1 plus beta times of IB is also fixing the value of IE as well. IE as well. So I can say across the load, the current is not going to change. Across the load, the current is not going to change. So lump sum, I can say the best most answer for this given question is been the constant current source. But still I feel this problem must have been designed into the better way as well, because many of these students might get confused. So I would request to each one of you need not to take so many important concepts from this question, because this question could have been designed into the better way as well. Yes. So lump sum, the answer is being option B. Option B. In the same sequence, the question number 39 do come into front of us. Question number 9 do come in front of us. Consider an op-amp circuit shown in figure below. The function of the above circuit is being, the 4 different options are being given: LPF, HPF, BPF and BSF. Tell me what could be the best most answer for this given question. What could be the best most answer for this given question? Which kind of the circuit it's been, whether it's been low pass, whether it's been the high pass, whether it's been the band pass, whether it's been the band stop filter. So answer have started coming. As per the gate, the answer supposed to be C. Anyone else apart from gate? Anyone else? So the next 1 minute is being remained. Chanchal is also saying the answer is being C. Good Chanchal. Good gate. The best most answer for this given question is being supposed to be band pass filter. My dear friend, whenever you have this kind of problem, no, your best most approach must be analyze the given circuit into the two extreme environment of the operating frequency. Let's take the DC and let's take a very high operating frequency, infinity. My dear friend, in case of F tends to infinity, no, what would happen? This capacitance would become short circuited. Why so? Because the XC, reactance offered by the capacitance, is being referred as a 1 upon 2 pi FC. If the operating frequency F is being so large, XC would become short circuited. My dear friend, if the XC becomes short circuited, what would happen? Even the V in would be completely gets grounded. The effect of the V in would not get transferred towards the output side. So one thing has been quite sure: if the operating frequency F is being infinity, V out is being null. And as the V out is being null, by default it can't be the high pass filter. High pass filter is being knocked off, and similarly it can't be the band stop filter. Why? Because in high pass filter, towards a very higher frequency, the gain offered by the system used to be maximum, it can't be 0. And similarly in case of band stop filter, again the gain offered by the system towards a very high frequency and towards very low frequency remains maximum. Yes, so only we had been left out with the two options, and that's been option A and option C. And now we can take the reference of F is equal to 0 as well. And once we'll take the reference of F is equal to 0, what would happen? Now the operating frequency is so low, this capacitance has been treated as open circuited. And once this capacitance is being treated as open circuited, my dear fans, this has been open circuited. Yes, sir. Now you yourself would be able to see the negative feedback is properly intacted. That means the virtual ground theory remains true. And as the virtual ground theory remains true, obviously the remaining process can be done. See what had been happening over here. All the way this V in had gone till this point. Now if you will try to understand, my dear friend, this branch is been completely isolated. As this branch is being completely isolated, whatever the voltage we had over here, the same voltage we are going to have here also. Yes, sir. As is being 0 is being 0, and from the virtual ground theory, this is also being 0. So the voltage across this terminal is being 0 volt. As there had not been any flow of current, R2 and R1 comes in series. Let's take the flow of current from the V out is being I, that would come in series with the R2 and R1. May I know what would be the voltage drop across the R1? That is simply gonna be R1 divided by of R1 plus of R2 into I, and that voltage drop is being simply given as 0. Or from the voltage divisor rule, this could have been written as V out into R1 divided by R1 plus R2 is equals to voltage across this terminal that had been 0. So obviously from here we can calculate the V out is also being 0 volt. So either you take the extremely high operating frequency, the output voltage is being 0. Either you take V F tends to 0, the V out is being 0. That means one thing is been quite sure, towards the lowermost frequency also the gain offered by the system is being 0. Low pass filter has been ruled out. You had been left out with a band pass filter only. You had been left out with a band pass filter only. Is that part clear to all of us? I don't find any of the student would have any kind of doubt, at least at this moment of mind. Yes, na? In the same sequence, I think we had to move forward, taking the next question as well. Here comes the question number 40, and I can feel many of the students would do the silly mistake in this problem. The two operational amplifiers are being connected and they had been given a proper negative feedback. And at last we need to find the value of V out. We need to find the exact value of V out. Tell me what could be the best most answer for this given question. Tell me. Tell me what could be the best most answer for this given question. I need to find the value of V out. I need to find the value of V out. So your time starts now. And I would request to the student, probably may not be comfortable in Hindi, but the tomorrow's 10 hours are gonna be very, very useful, because approximately 90 to 100 number of questions we are going to take from 3 different branches. Whether you are not able to understand my Hindi, but still you will be able to see the question and at least you can reply. And if you are replying the correct answer now, your confidence will boost up. That makes hell amount of sense. So the answer has started coming as per the Rahul Jaiswal. The answer is being 6 volt. Anyone else apart from Rahul? Ravi Hans, the answer is being 6. So yes, so many same answer had started coming, and as per them the answer is being 6. So whoever have got the answer as 6, definitely they are being extremely correct. This problem could have been solved from 3 to 4 different methods. Either we could have used the concept of superposition, at which I could have kept the V1 is equals to 0. With the help of 2 volt, I could have calculated the value of V out. Similarly, I could have kept V2 is equals to 0. With the help of V1 is equals to 4 volt, I could have got the value of V out, and I could have added them together. That's been the superposition theorem. Or otherwise, we could have used the different methodology as well. May I know what could be the different methodology? Just a minute. Yes. See what we could do over here. The negative feedback is being properly injected, and as the negative feedback is being properly injected, the virtual ground theories are gonna be same. So the 4 volt is being connected to the non-inverting, it would be same as the inverting. So the potential here over here, it's been 4 volt. It's been 4 volt. Not only that, even the 2 volt is being connected over here. So here the voltage is going to be 2 volt. Voltage is going to be 2 volt. Yes, na? And one more important thing, this has been a type of non-inverting amplifier. May you know what about the gain which used to be offered by the non-inverting amplifier? That used to be 1 plus feedback resistance RF divided by of R1 to my input voltage, and the input voltage is being 2 volt. Input voltage is being 2 volt. You yourself would be able to understand this has been my feedback resistance and this has been my series resistance. So here I could have written this as a 1 plus 5 divided by of 10 could have multiplied with 2. Could have multiplied with 2. Yes. So here it had becomes 1 plus of 5 divided by 10, that's been the 0.5. 1.5 into 2, that's been 3 volt. So we could have calculated this as 3 volt. This as 3 volt, and with the help of this many outcomes, definitely you could have got the answer very well. May I know how will you get the answer now? How will you get the answer now? See, if here the voltage has been 4 volt and here the voltage has been 3 volt, definitely you know very well the current which has been flowing towards downside from higher potential to lower potential, and that had been 4 minus of 3, that's been 1 divided by your 5. 1 divided by 5 used to be 0.2, and kilo will make it milli. So the 0.2 milli current had been flowing across this 5 kilo, and the same current would flow across the 10 kilo resistance as well, because being a ideal operational amplifier, the inverting and non-inverting terminal is not going to sink any amount of current. The next doubt would come at this point. May I know whether this current and this current would remain same? No, my dear friend. Here this has been an output terminal. Even the output terminal is allowed to source or sink the current. So obviously this current would not be same. So you should not take both of the branch currents to be same. No, you should not take that. You should not take that. Agreed? Agreed now? But anyways, with the help of this many outcome, we can find each and everything. So what had been happening, just try to understand in this way. This 2 milli is going to flow across the 10 kilo as well as 5 kilo, and this will give you the potential difference between this terminal and this terminal, and voltage across this terminal is already been known to be 3 volt. Once we'll add the voltage difference between this two terminal plus of 3 volt, we will be getting the answer as well. So here it becomes 0.2 milliampere current is going to flow across the 10 plus 5, that's been the 15. Keep in mind it's been kilo, and once we'll add with the 3 volt, we will get to know the voltage across the topmost terminal. Agreed? So 15 kilo and millis are going to get cancels out. 15 into 0.2 is gonna be 3 plus of 3 is simply making output voltage as 6 volt. So as far as this problem is being concerned, the best most answer is being 6 volt. The best most answer is being 6 volt. Let me take 2 or 3 more number of problems. Anyways, this problem had come once in gate electronics. I am not going to discuss much about this problem because a lengthy derivation sort of thing is still been there behind this problem, but still tell me what could be the best most answer. What could be the best most answer? Anyways, in this problem, the different datas are being given. The ripple voltage are being given. Everything is being given. You had to find the period of triangle wave is being. Triangle wave is being. The ripple voltage V ripple is being referred by IDC into the time period T divided by of the worth of capacitance which are being connected. Worth of capacitance which are being connected. You have to feed the data and you have to get the answer. You have to feed the data, you have to get the answer. Anyways, if we'll start understanding the concept behind this problem, no, probably 1 hour had to spend over this problem only. 1 hour had to get spent over this problem only. Anyways, the VR is being VDC into IDC into T divided by FC. You will be getting the remaining value. You will be getting the remaining value. So I would request to each one of you, Rahul, then No Name, Superior, Jai Singh, Abhishek Datta, Jai Singh. All of you are requested to attend the tomorrow's session, because in tomorrow's session, back to back 90 to 100 number of questions we are going to take in the same pattern. There I would place a timer also. I would place a timer over here. So when I would be showing the question, I would start or I would activate the timer also, so that within the pressure you will be able to smash most of the question. So tell me what had been the best most answer. The answer is being 0.697 millisecond. So all of the data you can feed over here and you can find the answer very well. Anyways, I am not going to take any more question apart from this 11 questions which we have taken, and we would take approximately 90 question. If you want, I can show you the all 90 questions because it's already been there with me, but that we are going to conduct in our Gate Academy 2.0 channel. There the mode of communication would be Hindi, but the student who are not well acquainted in Hindi, they should also be joining that session, because question would be there in front of you. Probably you may not be able to understand what exactly I wanted to communicate, but still you'll have a good amount of practice there in single day. Yes, चलो तो फिर आज की सेशन को we are going to close here itself and we would meet tomorrow on our 2.0. Bye bye, take care.